Hello and welcome to this video on why you can't travel at the speed of light. You might think that if you have a powerful enough rocket, you can just keep accelerating until you reach the ultimate speed limit of the universe. But according to Einstein's theory of special relativity, this is not possible. In fact, nothing with mass can ever reach the speed of light, no matter how much energy you give it. Why is that? To understand this, we need to look at how motion, mass, energy and time are related in Einstein's theory. According to Newton's laws of motion, which work well for everyday speeds, the momentum of an object is equal to its mass times its velocity. To change the velocity of an object, and hence its momentum, we need to apply a force for a certain amount of time. This is called impulse. The faster the object moves, the larger its momentum, and also the larger the impulse required to speed it up. But Newton's laws break down when we deal with very high speeds, close to the speed of light. In this case, we need to use Einstein's formula for momentum, which is mass times velocity times a factor called the Lorentz factor. The Lorentz factor depends on the object's speed and increases as the speed gets closer to the speed of light. For example, at half the speed of light, the Lorentz factor is about 1.15, which means that the object's momentum is 15% higher than what Newton's formula would predict. At 99% of the speed of light, the Lorentz factor is about 7, which means that the object's momentum is 7 times higher than what Newton would expect. This means that as an object approaches the speed of light, its momentum increases dramatically, and so does the impulse needed to accelerate it further. In fact, when the object reaches the speed of light, the Lorentz factor becomes infinite, which means that the object's momentum also becomes infinite. This implies that it would take an infinite amount of energy and time to accelerate an object to the speed of light. This is why nothing with mass can ever reach or exceed the speed of light. But what about light itself? How can it travel at this constant speed without any acceleration? Well, light has no mass, so it does not follow the same rules as objects with mass. Light always travels at the same speed in a vacuum, regardless of who observes it or how they are moving relative to it. This is one of the postulates of special relativity, and it leads to many strange and fascinating consequences, such as time dilation and length contraction. But that's a topic for another video. Thank you for watching, and I hope you learned something new today. If you liked this video, please give it a thumbs up and subscribe for more science videos. See you next time.